Welcome to standard form of linear equations. This is lesson 6.4 in our text. So standard form is going to allow us to graph equations using intercepts, and then one of our objectives is to write equations in standard form. So standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers. They're integers. We like them to be integers, and a and b are both not zero. X-intercept is the value of x when the y is 0, so our point would look something like x comma 0. So first off, let's find our intercepts. So here we have an equation in standard form. Notice how our a is 2, our b is 5, and our c is 6. So in order to find the y-intercept, remember x is 0. So if we replace our x with 0 and solve the equation, now for y, remember 2 times 0 is 0, so we're left with 5y equals 6. If we divide both sides by 5, we are left with y equals 6/5. So that is our y-intercept, so 0 and 6/5. And just leave it as a fraction. We don't need to bother with the decimal value there. So that's our y-intercept. Now to find our x-intercept, we are going to replace the y with 0. So now we are left with 2x plus 0 equals 6. If we divide both sides by 2, we are left with x equals 3. So our x-intercept is 3, and that point is going to be 3, 0. That's our point for our x-intercept. So using intercepts to graph lines is great, especially when they are in standard form like this. To take the time to rearrange this equation into slope-intercept form and go from there. It's a little time consuming. So using our standard form, we can plug in 0 for x and 0 for y to find our intercepts. So in this case, if the x is 0, we're looking for our y-intercept, okay? That means our y-intercept, remember that becomes 0, so that's gone. We divide by 5, our y-intercept is going to be 3. So that point right there, let me make that blue, that point right there is going to be our y-intercept. And then we're going to do the same thing with substituting in 0 for y. So we have 3x plus 5 times 0, right, which is 0, equals 15. And again, that's gone. So if we divide both sides by 3, we now have x equals 5. So our x-intercept is 5 now. So we can plot that point right there on the x-axis. See how great that is? And now we can just connect our points via a line, okay? Try to make it a little straighter than I did. But now we've graphed our line using those 2 points, and we haven't had to do a lot of work. Our numbers are great integers, and it becomes pretty easy to graph. Here's just a close-up of our intercepts and our graph again. So now here comes the hard part. And here is an equation in slope-intercept form, and we want to convert it to standard form. Okay, so remember, ax plus by equals c. So if we are thinking about that, ax plus by equals c, and notice how, here's our equation right now, y equals 2/3 x plus 6. Notice how in standard form, our x and our y are on the same side. In slope-intercept form, our x and our y are on opposite sides. So the first step in converting slope-intercept form to standard form is to get that x to the other side of the equation. So I'm going to subtract 2/3 x from both sides. And now I'm left with negative 2/3 x plus y, and I'm just going to put a 1y there just to kind of keep reminding you equals 6. So right now, we kind of are in standard form in that we have our x and our y on the left side, and that equals a number on the right. But this equation, standard form, requires one extra thing, and that is that a, b, and c are all whole numbers or integers, okay? So we want them to be, we want to get rid of any fractions. And again, now what we're going to do is think about this. We've got 2/3 x. So we want to get rid of that denominator of 3. So we're going to multiply everything in the equation by 3 because we are not allowed to just multiply one thing by 3, right? We have to multiply everything by 3. What you do to one side, we do to the other. So we're going to multiply everything by 3. When we do that with our x coefficient, the 3's are going to cancel out, and now we're just left with negative 2. If we would have done all of that math there, that would have given us negative 6 divided by 3, which is still negative 2. So it's negative 2 over 1. We really don't need to write that over 1 now. Now over here we have plus 3 times y, so that leaves us with the 3y, right? And then over on our right side of our equation, we have 6 times 3, which is 18. So now, if you look at your standard form of this equation now, we have negative 2x plus 3y equals 18. For some textbooks, some math teachers will let your a be negative. I personally would like you to avoid having this a value be negative and think about how we can change that to a positive. And again, all we're going to do is we're going to multiply everything by negative 1. Okay, so we're going to multiply everything by negative 1, and our properties of equality tell us that as long as we're multiplying everything in the equation by that negative 1, we're not changing the equation at all or the values. We're just making it look a little different, okay? So a negative times a negative becomes a positive, so we're left with 2x. Now here's where the difference starts to come in now. We have this negative 1 times 3, so that gives us the minus 3y. And then the 18 times negative 1 gives us negative 18. So here, if you look, I'm going to write both of these equations. They are equivalent equations. If you were to graph them, they would look exactly the same. They would be the same graph. They would have the same y-intercept. They just look a little different because we don't want that a to be negative. Why? Because you're likely to lose it if that a is negative. So it's just kind of one of those things that keeps our work organized, neat, and avoid any little errors along the way. And so there is my preferred method with the a value being positive. In our last example, and this is a great example of why we need different forms of linear equations. In this problem, we really don't have an independent and a dependent value. We are mowing lawns and delivering papers. We're making different amounts of money based on hours worked for mowing lawns and delivering papers, but our goal is to make $130. And so we could technically just mow lawns to make all of that money, or we could just deliver papers to make that money, but we really want to see the different options for making that $130. So I am just going to let X be the hours I mow lawns. Okay, so mowing lawns hours. All right. And again, I'm defining my variables. And then delivering newspaper hours is going to be the Y. Okay. So how are we going to make that money? We're going to make that money by $12 for every hour we work mowing lawns, plus $5 for every hour we deliver newspapers, then that is going to give us our total of what we want to earn. So here you can see how we have an equation. It was much easier to think about and write in standard form than to try and come up with a slope and a y-intercept. If you really want a challenge, go ahead and rearrange that into slope-intercept form, and you're going to see a crazy fraction for your slope, and even your y-intercept isn't really going to have much meaning at this point. But it's good to think about equations in a little bit different form because you never know when you're going to need them.